we are starting a convenience store chain, okay? Yes, we are. Kind of like it's going to totally not, it's 11-7, okay? 11-7. And what your job is to look at our projected growth. We're looking at opening 20 new stores each year. I need you to complete the table and answer the questions about our store's growth of 20 stores per year.
Wait, so we
Here we go. So, there's no difference from previous year's start. From 5 to 20, though, it went up by how much?
20.
20. So 25, I add my 20 store growth. I'm going to have,
20.
after 25, how many?
0, 20. Oh, 45.
Okay, then I'm going to go 65,
85,
85.
125, 145, 165, 185, 205.
Why did I write a 4? I don't know.
205, and then all 20.
And then these are all 20s.
Faster.
Okay, we got it. So what do we notice about the difference from year to year? It's always 20 or plus 20. If there's N stores, how many stores will there be next year? Every 3 years, how many are there?
60 more.
Which is 60, yeah, 60 more. So if there's N stores in 1 year, how many in 3 years?
And for 60.
I'm just showing this, that those are the same. So that repeated addition, that means 60 more every 3 years then. Okay, we're looking to grow our 11-7s. Okay? And we're going to do, Now, this is store option A for growth. We're going to pitch a separate option. The second plan would be to double the number of stores each year. I would like you to see what that looks like in our table and fill out the questions, please.
Oh, double it?
Yeah, these ones are going in Ireland.
Okay, number of stores.
They're Dublin. All right. So, if we have 5 stores to start, how many we have next? 10, then 20, 40, 80, 60, 320.
640, 1,180, 1,560, 5,120.
Okay, so you're seeing that our difference is increasing every year. From previous year, this went up 5. What are you guys noticing about this
It's
pattern?
the same thing, just a line down.
Yeah, because it's doubling, right? So it's like half of the previous year thing then. Sorry, I was talking. Okay, so each year it's increasing by a factor of what?
2.
Divide. We got all 2s, baby. Okay? No. It would be 2 to the power of X. But we'll look at that in a second. Actually, let's do that before we do any more. How many stores are we starting with?
5.
And what am I doing to those stores? How many times? A variety of times. So this would be the function. Notice, where's my exponent? What is my exponent right now?
How many times?
A variable. How many times I'm going to multiply by 2? Okay? Now, what do we notice about the difference year to year?
It doubles.
It doubles. Okay, I like that. What do we notice about the factor?
Stays at 2.
Always 2. Because last time we were adding 20 over and over. This time we're multiplying by 2 over and over. If there's N stores, how many stores will be there next year?
N plus N.
2N. N plus N also would work. What do you notice about the difference every 3 years?
Double.
It's times 8. And the reason for that is it's 2 times 2 times 2, or 2 cubed is 8. So if I double 3 times, it is 8.
We don't have the.
What's the factor every 3 years then? Times 8. Yep. And if I wanted to write that as N years, every 3 years is going to be 8N. Or I like to think of it as M times 3 times 3 times 3. Which is N times, 2. I got ahead of myself. 2 times 2 times 2, which is 8N, or N times 2 cubed. So those are a variety of ways to think about the same thing. That's probably what most of you wrote down, and that is excellent. But this is I want to make sure everybody right now can use their calculator. I want everybody to use this in their calculator to find 8 years, please. Make sure you can use your calculator, 8 years. And then it should match up with your table. So we're going to be doing more and more. That's why I wanted to make sure you can use your calculator. One more thing. We're going to match context to a variety of ways to represent that context. So we got situation 1. A social media person, they're tripling their followers every year for 4 years. Situation 2, 80 gallons of water, and we're adding 3 gallons of water to it each minute for 4 minutes. You need to match the variety of representations of the situation to the correct situation. So let's look at let's look at A. We'll go A and D and then match them. We'll go like down the rows here. So, which one is times 3 over and over? 1 or 2? 1. Yeah. So this is going to be situation 1, because I'm tripling. So times 3 times 3 times 3. Let's look at D. If I'm adding 4 times 3, that would be 4 different times. If I'm adding over and over, that would be situation 2. Let's look at the table. What's happening on table B over and over? Times 3, so situation 1. Let's look at E. Plus 3, plus 3, plus 3, plus 3. Okay, which one did we add 4 times? 2. Which one did we multiply by?
1.
So here's why. This one's a little tougher. 3 times 3 times 3 times 3 is that 81 right there. You guys seeing it?
Yeah, 81.
So if we want to, this isn't even on there, but if I want to write the function for the situations, if I have 80 followers and I'm tripling, that function would give me how many followers there were after each year. This function would give me water. That one's linear. A y-intercept and a slope. Are you guys seeing the difference between the two functions, even though we have same numbers? Yeah. Cool. You are going to do your lesson summary next.
Already?
Oh, yeah. That's it. Homework is in the basket when you finish.